So we're going to look at the surface area of 3D objects. And the surface area is the total area of all of the faces of a 3D object. So the hint here is to think about what does the net of this shape look like. So if I was to unfold the shape, what would I be left with? So we want to find the surface area of this cuboid in our first example, and the cuboid is 8 by 2 by 5. So if I was going to unfold that cuboid, I would end up with 6 different rectangles. But you know the properties of a cuboid, that the top and the bottom are the same size, the sides are the same size, and the front and the back are the same size. So that way I can actually just work out 3 rectangles and then multiply everything by 2. So I'm going to draw myself some sketches. So I want to look at the front and the back. I want to look at the top and the bottom, and I want to look at the 2 sides and work out what the dimensions are going to be. So let's go to our picture and let's get a highlighter. So I want to look at the front. So the front is this shape here. So you can see that if I put my dimensions onto my sketch, I've got one dimension of 5 and I've got centimeters, and the other dimension is 8 centimeters. So the area of this front is going to be 5 times 8, and that's going to be 40 squared centimeters. Now, I want to have a look at the top and the bottom. So let's use a different color highlighter. So the top and the bottom is this dimensions here. So you can see that the top has a length of 8 centimeters and the other dimension is 2 centimeters. So the area of that particular shape is 8 times 2 equals 16 squared centimeters. So if we get rid of all our highlighting so that we can look at the sides, the side is this rectangle here, and you can see that the dimensions on the side are a length of 2 and a height of 5 centimeters. So the area of the 2 sides is going to be 2 times 5, and that gives us 10 centimeters squared. And now I need to add them all together. So the area equals, and I'm going to put it into brackets because that only gives me 40 plus 16 plus 10 gives me 3 of the surfaces, and I have to remember for the surface area, I'm going to write an essay for surface area, I need to multiply it by 2 because I have 6 rectangles altogether. And so that gives me 66 times 2, which gives me a surface area of 132, and its area, so it will be in squared centimeters. Now, what about the area of this triangular based prism? So, what would I end up with if I unraveled the net of this triangular based prism? Well, first of all, I would have 2 triangles that are identical at each end. So I'm going to draw a sketch of that triangle. And the base of the triangle is 4. I'm not interested in the sloping side. I'm interested in the perpendicular height. And so the perpendicular height to that base is 6 centimeters. So it's 6 centimeters and 4 centimeters, and I've got 2 of them. So I know that the area of a triangle is a half times the base times the height. So it's a half of 4 times 6 equals 12 square centimeters, and I want 2 of them. So I'm going to go over here to my total surface area, and I'm going to say I want 2 times 12. Now, what about the other shapes? So you can see it's an isosceles triangle, and so this rectangle here on the side, different color, is identical to the rectangle that's on the opposite side, so kind of the sides of your tent. And they're both 7 by 12. So again, we've got 2 of these, and they're 12 centimeters by 7 centimeters. So we know that area equals length times breadth. We've got 12 times 7. That gives us 84. So we're going to add on over here 84, or 2 multiplied by 84. Then the final shape that I've got is at the bottom here. So I'm just going to draw it in purple. So you can see we've got the base of our triangular prism, and the dimensions of it are 4 by 12. And we've just got one of those. So the area is going to be length times breadth. It's going to be 12 times 4, and that's going to be 48 squared centimeters. And so we're going to have to add on 48 to our total. And if we add all of that up together, we're going to end up with a total area of 24 plus 168 plus 48, which gives us 240 squared centimeters, and that's our surface area of our triangular based prism.